Okay, so we'll see. Okay. Just wait. Guys, wait for a 1 minute. Light gone, so I have to connect it from mobile. My voice is coming, guys. Is it coming? Okay. So, okay. So we were discussing the problems. Okay. Yeah. So this was the problem. Okay. So I hope everyone got the result, or anyone is having facing any problem. It was a simple substitution problem. So anyone if facing a problem in this, they can ask. I will solve it. Don't worry. So this was your problem. Okay. So this is RLC network. This particular is your RLC network. So R, L, and C. So this is your RLC network. RLC. So what is the value of R is given? R is given as a 2 ohm. And what is the value of L? It is 1 millihenry. And what is the value of a C? 0.4 microfarad. Yeah. And what they had asked you to find? What they had asked you to find? Half power frequency, resonance frequency. Resonance frequency. I am writing by notations. Okay. Resonance frequency is denoted by omega naught, and half power frequency is omega 1 and omega 2. Okay, half power frequency. The quality factor is Q, and bandwidth is bandwidth only. So first omega naught will calculate. So omega naught they had asked you in radian. So what is omega naught? 1 by root under L into C. So if you are substituting, that is 10 to the power minus 3, and C is 0.4 into 10 to the power minus 6. So guys, how much you will get? 1 divided by, if I am taking 4 into 10 to the power minus 10, right? And we are getting 1 by 2 into 10 to the power minus 5. So 2 into 10 to the power 5 radian per second. Everyone is getting this result, omega naught value. Or I did any mistake, means 1. Yeah, okay. Yeah, you are right. So this is 10 to the power 5 divided by 2. So 10 by 2 into 10 to the power 4. So how much you will get? Yeah, 10 to the power 4 you will get. So how much you will get? 5 radian will get. Is it like that? Mm, yeah, 50k. So 50k radian per second. So everyone got this result? 50k radian per second. Okay, just wait, someone is coming. Yeah, so this is the 50k radian per second, it's the result. And what is the quality factor? Quality factor is, you can write omega naught L by R. So you have a 50k, 50 into 10 to the power cube into L value is 10 to the power minus 3, 1 millihenry. Okay, and what is the R value that given? R value is 2. So how much you are getting? 25. So this is your quality factor. Okay, and what will be the bandwidth? R by L. So R is 2 and L is 1 millihenry. So how much you will get? 2k radian per second, right? 2k radian per second. Okay, so this was the radian. And how we will calculate the omega 1 value? Half power frequency. This is omega 1, this is omega 2, this is my bandwidth, and this is my omega naught. So I need to calculate this value. So this value, from this value I need to minus, this will be bandwidth by 2 and this will be bandwidth by 2. So I need to do omega naught minus bandwidth by 2, right? And omega naught value, what we got? 50k. And what is the bandwidth? 2k divided by 2. So what we are getting? 49. 59k radian per second. And for omega 2, this value we want to calculate. So it will be omega naught plus bandwidth by 2. So 50k plus 2k by 2, we are getting 51k radian per second. So you solve like this, right now? You guys have solved like this only. Okay, so we are getting omega 1 value, omega 2 value. Now if anyone will ask you what is the Z value? Z value, in the questions they are asking, find the resonance factor, half power frequency, quality factor, and the bandwidth. Yeah, this was the question only. So we had calculated perfectly the things. Okay. Okay. You know, actually, if what value you are getting, quality factor, this is 25. Okay, write one formula. Actually, the omega 1 and omega 2 value na, it's if you will get quality factor less than 10, so you cannot use this formula. Okay, this formula you cannot use. But if your quality factor is greater than, if you are getting greater than 10, then it's fine. Okay, in the most of the case you will get this formula only. So write one important formula for a quality factor. Omega 1 is minus R by 2L plus root under R by 2L the whole square plus 1 by LC. And omega 2 is R by 2L plus root under R by 2L the whole square plus 1 by LC. So by doing the discriminants in the half power factor, I had shown you how to get these things. You will get one equation. From that equation you need to discriminant it and you will get, this is the shortcut. If you are getting the quality factor less than 10, then you can apply this. But if the quality factor is less than, if the quality factor is greater than 10, then you can apply this formula. If the quality factor is less than 10, then you have to go with this formula. Minus R by 2L is what? Minus R by L is bandwidth by 2. So bandwidth by 2 I am getting. And for finding the omega naught value, this we are doing same thing. This particular is getting the same thing. R by 2L the whole square, bandwidth by 2 the whole square plus 1 by LC. 1 by means omega naught the whole square. Okay, omega naught the whole square. So just remember, just incorporate in your notebook this important formula. Okay guys, is it clear? So for this question, this is right. This 49 and 51 is right. Even if you will go with this formula also, you will get the close value of this. So that's why if quality factor will less than 10, then you will get the variations. So for that, you need to go with this formula. Is this clear to everyone? Is this clear to everyone? Okay. So there is one question. One or two questions will solve. I think battery is 9% only, so I think it will get off in midway. So maybe we'll not continue the class today. So let's see up to how much we can do. So the question is, find the resonance frequency of the below given network, right? So this is your network, this is your R value, this particular is your inductor value, and this is your 1F, this particular is your 1F. Here you are getting 4 Henry and this is 20 ohm. So yeah, so these things you have. So you need to find the resonance frequency. Procedure for finding the resonance frequency for any circuits. How can you find the resonance for any circuits? I told you, I taught you yesterday only. So this particular is your Z1, this particular is your Z2, and this particular is your Z3. So what is the equivalent resistance? Equivalent resistance will be Z1 parallel with Z2, Z1 parallel with Z2 plus Z3. Am I right? So what is the value of a Z1 you will get? Z1 value, what you will get? J into 4 omega. And what is the J into 4 omega? Minus J by omega, omega C. So this is C. So you are getting the Z1 value is how much? J common 4 omega minus 1 by omega. This is your Z1 value. And what is your Z2 value? Z2 value is J by omega only, minus J by omega. This is your capacitor. So you need to multiply this Z1 into Z2 divided by Z1 plus Z2. So Z1 into Z2 divided by Z1 plus Z2 plus Z3. So if you will do it, J into omega minus 1 by omega into minus J divided by omega plus J into omega minus 1 by omega minus J upon omega, and what is the Z3 value? It is 20, right? So Z equivalence you are getting. So guys, what value you will get? J square will be give you minus 1, and minus minus will become plus. So this will be omega minus 1 by omega into 1 upon omega only. And from this we can take the Z as a common, and if you will take the Z as a common, omega minus 1 by omega minus 1 by omega plus 20, right? So solve this and just tell me what value you will get. Omega square minus 1 upon omega square divided by this omega, and omega is getting multiplied. This is your J, and what here you will get? That omega will be common. So omega square minus 2 divided by omega. So this particular will get cancelled out, and plus 20. Okay, so what you are getting? Omega square minus 1 by omega into omega square minus 2, and this j is going upside, so it becoming minus j, and this is plus 20. So guys, what I told you, for resonance frequency the imaginary term will be 0. This is your z equivalent. So this imaginary term, if you will make it as a 0, so omega square minus 1 divided by omega into omega square minus 2 is equals to 0. So what value you will get? Omega value plus minus 1, but the frequency cannot be negative, so omega you are getting as a 1 radian per second. Yeah. So I told you the calculation, maybe the calculation may be mistakes, you just try by yourself. Okay. So what value? Okay. uh this is 1. I'm taking this as a 100. In questions just change it as a 100. Rest everything is same, you will get the same answer. Okay, this is 1. Understood guys? So you are getting z1 value is j omega minus j by omega. Z1 value is j as a common, omega minus 1 by omega. Z2 is minus j by omega, minus j by omega. And you are doing z1 z2 divided by z1 plus z2 plus z3. So if you will do z1 into z2 divided by z1 plus z2, you will get this particular results. After solving this, and your z3 is 20, after solving this you are getting equations like this. Okay, so if you are getting the equations like this, then you are equating to 0. What value you are getting? Omega value 1 radian per second. Is this clear guys? Is this clear? Anyone having any doubt, they can ask. Okay, Prasanna, is this clear? Vaishnavi, is this clear? Okay, if it, okay, 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 yeah, see this part. Is this clear for everyone? Okay. Okay, so if it is clear, then go for the last question for the resonance. You need to find the voltage V0 in the below given electrical network when your circuit is operating at resonant frequency. Okay, resonance frequency of tank circuit. Okay, and you have a tank circuit like this. This is your tank circuit. This is your ideal tank circuit, suppose. And you need to find the value V. Your option is this particular is your R, and this value you need to get. V by 2, B is V, and C is 2V, and particular D is 0. So guys, if it will operate at the frequency of the tank circuit, that means this will get, this imaginary terms will get open, right? Yeah, yeah, open circuit. So yeah, so the voltage will be 0. It's nothing. You got the answer. So it's very easy. Okay, solution is very simple. If it will operate at the resonant frequency, this part will get open, because for parallel, this is the parallel combinations, and we know that if XL is equals to XC, here we can say, we will say BL is equals to BC, and if this will happen, your Y will become 0, and if Y is becoming 0, that means Z is becoming infinite, so it will become Z equivalent will be infinite. So you are getting V, and this is your R. So what the voltage you will get, all the voltage will come across this, it will not go in this part, so your V0 value will be 0. One small question, last one small question. So you need to find, question is, you need to find the circulatory current in the below given electrical network. So this is your network, means you have an ideal tank circuit, and in ideal tank circuit you need to find the circulatory current. So how you will do it? In ideal tank circuit you need to find this circulatory current. This is L, this is C, and you need to find this I circulatory current, and here you are getting the voltage V. So guys, what will be the value of this is V, that means this is V. So what will be the current in this IXL current? IXL current will be V divided by XL, right, which will be equal to this current, because there is a no resistance, so whatever the energy it will get, and your IXC current is V by XC. Okay, so at resonance, what's happening at resonance frequency, this circuit is becoming open, right? So this is becoming like this. So where will be the current flow? In this only. Okay, so these two current will be same. This is called as a I circulatory current. IXL is equals to your IXC, and you have to substitute the omega value is omega naught value, that is 1 by root under LC. So what you will get, put V, XC value will be omega into C, and XL value is V by omega L. So if you substitute the root under so this is omega naught, this particular is your omega naught, so omega naught value is 1 by root under LC, so root under LC divided by L, and here also V into 1 by root under LC into C. So what you are getting the circulatory current, V into root under C by L, V into root under C by L. So this is your I circulatory current. These things will come in a power electronics, V into root under C by L. Okay, so every chapter of the network is completed. Last two chapter means filter is a very one page chapter, and graph theory is very easy chapter. So write the next chapter as a seventh chapter, we can say it's graph theory. Okay, graph theory. It's a very easy chapter. So network theory, what do you mean by graph theory? We are studying the figure, means diagram of the network with the help of a graph theory. Okay, so write one first heading, network topology. Network topology. What is the meaning of a network topology? It is the study of the network properties by investigating okay, so network topology is the study of network properties by investigating the interconnection between branches and the nodes. Interconnections between branches and nodes. Okay, so I hope you know the branches, what is branches and what is nodes. We already discussed about the branches and nodes in a first class itself. In the network topology, any network can be replaced by a graph. Write it down. In the network topology, any network can be replaced by a graph. Okay, and to develop the graph is element and to develop the graph is a element is replaced by either by a straight line or arc or a semicircle. Okay, just wait, I will tell you what is the semicircle, what is line, where we will represent these things. Okay, so graph, and to develop the graph okay, and to develop the graph, the element in the network is replaced by either by a straight line or arc of an semicircle or arc of an semicircle. Okay, so if voltage source will be placed, so voltage source element, how can we replace voltage source element? Short circuit. Voltage source is replaced by short circuit. Okay, what about the current source? Current source will replaced by open circuit. While the graph remain while the graph it will not be remain, it retains all the nodes, means nodes will be present, all the nodes of original network. So guys, what you had understood from this, I am giving you one simple network and the network is look like this. That's very, this is your capacitor, this is your resistor, and this particular is your, this is the network, positive negative, and this is your, okay. So here what you see, number of branches is greater or nodes are greater? Oh, nodes are less, branches are greater. Okay, but yeah, but in a graph conversion na, you always remember number of branches of the network will always be greater than or equal to the number of branches of the graph. Okay, number of branches of the network will always greater than or equal to number of branches of the graph. So guys, you guys tell me, what will be the network, means if we'll draw this as a graph terminal, so how can we draw this particular as a graph? So this will be simply shorted, right? This particular will be get shorted. So, and if you will put the elements, so it will look like this, it will look like this, okay, and it will get shorted. Okay, and if you will remove the elements, your graph will look like this. Means how many nodes are there? 1 2 3 4. How many nodes are there? 1 2 3 4 nodes are there. Okay, so you are putting 1 node, 2 node, 3 node, 1 2 3 4. So this is shorted. Okay, this particular, this particular, this particular, this particular you are making. So you are just making, just drawing roughly the graph, all the nodes are present and you are drawing like this, and in that you have to give the directions like this, anywhere, it's up to you. Okay, anywhere you can give the directions. Okay, so just wait for 1 minute, I'm putting in charge my phone. Okay. Yeah, okay. Let me remove this. So guys, write the next topic, augmented incidence matrix. How we'll find the augmented incidence matrix? For this graph only, we'll doing augmented incidence matrix. Okay, so suppose I am taking this network like this. If I have a graph, it's like this. Okay, I'm simply drawing one particular graph. This is my one particular graph. So for finding the augment matrix and all, you need to give the name of the nodes. A node, this is your B nodes, this is your C nodes, and this is your D nodes. Put the directions. Okay, put the directions like this. This is your 1, this particular is your 2, anyway, this particular is your 3, this particular is your 5, this is your 4th branch, and this is your we missed for 5th, 4th, and this is your sixth branch. Okay, now what you have to do, you have to write the branches like this. Okay, make the column like this. 1 2 3. How many branches are there? 1 branch, 2 branch, 3 branch, 4 branch, 5 branch, and this is your 5th branch, and this is your 6th branch, right? Okay, now you have to make the nodes. A nodes, B nodes. How many nodes are there? 4 nodes. C nodes, and like this as a D nodes. Now you have to put zeros and 1. So in A branch, in A node, 1 is coming. 1 is coming in A node. Guys, 1 is coming in A nodes from anywhere. Incoming current is coming from anywhere. 1, this particular. So put 0. 2 is coming. It's not coming. Put 0. 3 is coming. Yeah, 3 is going. 3 is leaving. Leaving means consider leaving. It's up to you. Whatever you want to consider. If you want to consider it's negative, it's also fine. If you want to consider it's a positive, it's fine. So leaving I am considering as a positive value. And entering I am considering it as a negative value. It's up to you. So leaving. So 3 is leaving. So it's positive. 4 is leaving. So it will be positive. 5th is leaving. So it is positive. 6 is coming. No. 0. What is for B? See it for B. 1 is coming. No. 2 is entering. Entering means negative minus 1. Okay. 3 is coming. No. Okay. 4 is entering. So entering means you have to give minus 1. And fifth in branch 5th is not coming. 0. 6th is entering. So minus 1. Oh Prasanna, please tell about the C. What the value will get in this C? What the value will get in C? Okay, 1. After that 0. After that 0. Okay. After that 0. After that no. 5 will not be a 0 in C. See, 5 is coming. See the upside. 5 is entering. So it will be minus 1, na? Right? See, in C branch. So it will be minus 1. Okay. So this will be minus 1. And what about 6th? 6th will be 1. Plus 1. Okay. Priyanka, now you tell for a D. What we'll get? Wait. Just wait. Yeah. What you are telling? Minus 1. 1. Minus 1. 0. 0. Great. So guys, what our means consumptions was, assumption was that incoming means it's up to you. Whatever your wish, you can assume. Incoming means negative and outgoing means positive. So if you will add this 1 1 2 2 minus 1 1 we are getting. So yeah. So if you will add this, not this, you will get the 0 value, always 0 value. 1 minus 1 0, 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 minus 1 minus 1 0. Got it? See this part. and do the column additions. See this particular part. Okay, I'm saying in this particular column you are getting 1 minus 1 as a 0. In this particular column you are getting 1 minus 1 as a 0. Additions will be 0, 0, right? This is also 0, this is also 0. So means what you had assumed, it's correct. So for cross verifications. Okay. So this is your incidence matrix. Now there is one, and it is denoted by, incident matrix is denoted by A of A. Okay. Now there is one reduce incident matrix. One reduce incident matrix. So you can ignore any one branch. Okay. So if you ignore, means reduced incident matrix. Reduced incident matrix. It can be denoted by A zeta. So there was 4 nodes. Then you should take 3 nodes only. Okay, A, B, C. But column you have to take all column. 1, 2, 3, 4, 5, 6. So D part you can ignore. So what value we will get? 0, 0, 1, and this was 0, minus 1, 0, and this particular was 1, 0, 0, and this fourth one was 1, minus 1, 0, and this 1, 0, minus 1, and this 0, minus 1, 1. So why I had ignored it? Because we know the summations is 0. So the missing value is minus 1, missing value is plus 1, missing value is minus 1, missing value is 0, missing value is 0, missing value is 0. Check it. We are getting minus 1, plus 1, minus 1, 000. So directly, so that we can directly ignore. So in the examinations, if they are giving you a reduced incidence matrix, so there will be one opposite sign will be present, right? One opposite sign will be present. So guys, till now it's clear, or any doubt? So this is your reduced incidence matrix. If any doubt, you can ask. If any doubt, you can ask. Prasanna, any doubt in this particular thing? Write the next topic, properties. Properties of incidence matrix. Okay. So this is the properties I am dictating. Just write it down. So the unit entries in a column identity the nodes of the branch between which is connected. Write it like this. The unit entries in column. Unit entries in a column identify what? It identify the nodes of the branch between which is connected. So directly we can say now which is connected. So what is the meaning of this? It's a very simple meaning. So see your incident matrix. So we can directly say that say that 3 branch, 3rd, 4th and 5th branch is connected. 2nd, 4th and 6th branch is connected in node B, and in C only 5th and 6th branch is connected, and in node D only 1st, 2nd, 3rd is connected. That is the meaning of this particular statement. The unit entries in a column identify the nodes of the branch between which it is between which it is connected, better like between which it is connected. Okay, and the second statement, the unit entries in the row. So this was for column. The unit entries in row identify the branch, incidents at the nodes, branch incidences at the nodes. Okay, the unit entries in the row identify the branch incidents at the nodes. So see like this, you are getting here as a 2 4 2 4. So in node B, which branch? 2 4 and 6. So 2 4 and 6 in node B. In node B, which branch is coming? 2 4th and 6th branch is coming. 2 4th and 6th branch. So that is the meaning. The unit entries in a row wise you are seeing. This is your column wise. Means the unit entries in the column identify the nodes of the branch between which it is connected. So first see this particular column. So in this column, column means this is your column. So this is your first branch, right? This particular is your first branch. So this is column wise. So in a column wise, which node it is connected? C and D. So in node 1, which is connected? C and D. So from where to where current is flowing? From where to where current is flowing? From C to D, because we had assumed leaving as a positive, entering as a negative. So we can directly say from C to D our current is entering. What about the second column? This is your second column. So from where to where current is flowing? From D to B. From D to B. So this was the first statement meanings. And if you will see the row wise, sorry, I said mistakenly in the first statement. So first statement you have to see like this. Okay, you have to see like this. The unit entries in the column. So you have to watch the column. So in a column you are getting a C and D. So that it's telling about you from where to where current is going. And if you are seeing from this to this, so it will tell you at particular node which branch is connected. So at particular node which branch is connected. So for A node, which branch is connected? 3 4 5. For B nodes, which branch is connected? 2 4 and 6. Okay, so write the third statement. If the degree of the nodes is 2, then it implies the two branch are incident at the node. Implies the two branches are incident at the node. Nodes, and they are connected in series. So what is the meaning of this? I will tell you. If the degree of nodes you are getting 2, okay, so if this and this particular thing, if the degree you are getting as a 2, then it means the element is connected will be the element will be connected in series. Okay, in series. So what is the meaning? Means any branch, see any branch where you are getting degree 2, any node. So here the degree is 3, 1 2 3. Here is also degree is 3 only, 1 2 3. And here is also degree 1 2 3, and here it is also 1 2 3. So in these questions we are not getting degree. So suppose if you are getting in any node degree, you have to see with a row wise, and you are getting only 2 value, that means its a degree is 2. So what is the meaning? So that means in that particular node will be connected in series, in questions we will see these things. I will tell you there, because here we are not getting this degree things. I will tell you. Okay, for now write it down like this. But for column of the incidence matrix, columns of the incident matrix with unit entries is only 2 identical. So see the meanings. Identical is coming. Okay, identical is coming. This word is very very much important. So if you are getting in a column incident matrix, if you are getting a unit entries identical, you are getting the incident matrix identical incidence matrix. So what is the meaning of this? Into identical row. Okay, into identical row corresponds to branches, with same end nodes, and hence they will be parallel. Okay, so column of a incident matrix, if you are getting a column of a incident matrix with a unit entries in a 2 identical row, like see, if you have something value, this is your row, and here this is my row 1 and this is my row 2. Okay, so what the statement is saying, column of the incident matrix with entries in a 2 identical row. Okay, so yeah, like this. So this is my row 1, I am assuming this is my row 1, this is my row 2. If here also value is coming 1, if here also value is coming 1, and if you are getting -1 here, and here, if you are getting a -1 here, so it's showing the identical. It could be 2 row, 3rd row, 4th row. What is the meaning? This row and this particular branch, this branch and this branch are parallel. This is like parallel connections. Okay, the meaning of this is this only. We'll see in the questions. So if you are not understanding, it's not to worry. We'll see these things in the questions, how it's happening. Okay, and incident matrix is a complete mathematical descriptions of graph, and if the incident matrix is given, the corresponding can be easily constructed. Okay, the fourth one is incidence matrix is complete mathematical description of a graph, and if the incidence matrix is given, the corresponding circuit can be easily constructed. The corresponding circuit can be easily constructed. Okay, so this was the some statements about the properties of an incidence matrix. We'll discuss, you will understand this particular and this particular when we'll solve the problem. Then only you will understand how it is parallel and how we are getting as a series. This is to means like if you are having a incidence matrix, then you can comment about the behaviors of the circuits. And this particular means third and fourth is like that, how it will be in a series. If the degree of the nodes is 2, then it implies that two branches are identical at the nodes and they are connected in series. And what is the meaning? So if the incident matrix with a unit entries is 2 identical rows correspond to 2 branches, means identical row is row 1 and row 2 corresponds to 2 branches. This is my branch 1, this is my branch 2, means column 1 and column 2. So this column 1 and column 2 will be parallel like this. Okay, with the same nodes. So same nodes means this is my node A, this is my node B. Okay, so at node A to node B, one current is flowing. At node A to node B, one current is flowing. So this particular two, we are getting a parallel. So this is describing these statements. Okay, so write the next headings, trees. Okay, trees. So what is trees? Trees is connected subgraph that connects all the nodes of the network, but it does not consist of any closed path. But it does not consist of any closed path. Okay guys, means you have a graph like this. So this is your node A, this particular is your node B, this is node C, and this is your node D. You had constructed from one electrical circuit. So from this you want to make a tree. What could be your answer? It should be like this. Okay, so my all nodes are connected. 1 2 3 A, B, C, D, but I am not getting any closed path. And it could be like this also, A, B and C and D. So there can be a many trees you can form from the graph. So it is the subgraph of this. So what is the missing part? Missing part is this is your missing part. What is the missing part in this? This is the missing part in this. So in examinations they will ask you, you have a graph from that, or if you have a network, from that network how many trees can you form, how many this kind of a combinations can we make it. Okay, I will tell you the formula. First write it. The branches of a tree, the branches of a tree are called as tree branches. Tree branches. So this branch, this particular branch, it's known as a tree branches. Okay. Or we give a different name, that is twigs. Twigs. Okay. And generally they are represented by solid lines. And so this is my solid line, this is my dotted line, and generally they are represented by solid lines. Okay. Or thick lines. So total number of a tree branches equals to the total number of tree branches equal to n minus 1. So how many nodes are there? First node, second node, third node, fourth node. So how many total number of tree branches will get? 1, 2, 3. So nodes are 4 minus with 1. So 3. In this also you will get 1, 2, 3. So 4 minus 1, 3. So always your tree branches will be minus of 1 only. Means node minus 1. Okay. Okay. Now write the sets of branches which are disconnected to form a tree is called as coat tree. So what is the dotted line? Okay. The set of branches which are disconnected, the set of branches which are disconnected, this is disconnected to form a tree is called as coat tree. So there will be one question, then how can be the coat tree? The coat tree branches, and means you can write first the coat tree branches is known as links. Remember this statement, coat tree branches are called as links. So they can ask you what is twigs, what is links. So or we can say cords, links or cords. And generally they are represented by dotted line. And what is the formula for your coat tree? That is b minus n plus 1. Okay. Or you can write, so b is for branch, or you can write the total number of links. Total number of links is nothing but b minus n minus 1. So here how many branches are there? Total number of branches, 1 branch, 2 branch, 3 branch, 4 branch, 5 branch, 6 branch. Okay. So we will put 6 minus nodes 4 minus 1. So how many coat trees you are getting? Total number of links, how much you are getting? 6 minus 3. That is 3. So see, 1, 2, 3, 1, 2, 3. So in every tree you will get number of coat trees or links will be 3 only. And total number of possible trees how much possible trees you can make from a graph. So this is the formula: total number of possible